Hello students, welcome back to my channel. In previous session we have to complete ideal and non-ideal solution. In this session we are going to learn Geotropic mixture. Geotropic mixture. My dear students, let's start with the important topic, that is Geotropic mixture. What does mean a geotropic mixture? Two liquids boils at constant temperature and cannot distill unchanged their composition is called azeotropic mixture. Yes, two liquids boils at constant temperature and can be distilled unchanged their composition. Unchanged the composition is called a geotropic mixture. Yes, let's try to understand. I am giving example for this. Let us, I am taking two containers. One container A liquid and another container has B liquid, A liquid and B liquid. And these two liquids are combined to form a AB liquid. To form a AB liquid. AB liquid. To form a AB liquid. AB liquid has constant boiling point. AB liquid has constant boiling point. Constant boiling point. If AB liquid is vaporized, AB liquid is vaporized. It is a liquid phase. It has vapor phase. Liquid phase and vapor phase. In this liquid, at constant boiling point, the vapor phase and the liquid phase has same composition. Same composition. Liquid phase and vapor phase has same composition. What does mean? For example, A has 70% and B has 30%. Let's imagine 70% of A and 30% of the B. At that constant boiling point, there is no changing of composition. There is no changing of composition. That point is boiling point. That boiling point is a constant boiling point. Constant boiling point. This mixture is a azeotropic mixture. This mixture is a azeotropic mixture. Yes. Let's once again listen the definition. Two liquids boils at constant temperature and can distilled. Distilled means we can giving the heat and unchanged their composition is called azeotropic mixture. Azeotropic mixture. So these are formed by non-ideal solution. See, they are formed by non-ideal solution. They are formed by non-ideal solutions. They are formed by non-ideal solution. Yes. Next, types of azeotropic mixture. Next is the types of azeotropic mixture. Let's move on. Types of azeotropic mixture. Yes, definition is okay. Two liquid boils at constant temperature and can be distilled unchanged their composition is called azeotropic mixture. Generally, azeotropic mixtures are non-ideal solutions. Non-ideal solution. Azeotropic mixtures are two types. Azeotropic mixtures are two types. So let's move on. Types of azeotropic mixture. Types of azeotropic mixture. Let's move on. Types of azeotropic mixture. There are two types. There are two types. Minimum boiling azeotropes and maximum boiling azeotropes. There are two types. See, there are two types. Minimum boiling azeotropes and maximum boiling azeotropes. Yes. Let's start with the minimum boiling isotopes. Minimum boiling isotopes. What does mean minimum boiling isotopes? The minimum boiling isotopes are the mixtures, two liquids whose boiling point is less than either of two pure components. They are formed by non-ideal solutions showing positive deviation. Positive deviation. Yes, what is minimum boiling isotopes are the mixtures. See, minimum boiling azeotropes are the mixtures two liquids whose boiling point less than either of two pure components. They are formed by non-ideal solution showing positive deviation. Positive deviation. Yes. Which type of solutions can show minimum boiling isotopes? The non-ideal solution which are showing positive deviation, they are having minimum boiling isotopes. Yes. See, for the solution shows positive deviation from Raoult's law, there is an intermediate composition for which vapor pressure is maximum and boiling point is minimum. Yes, for solution showing. See, next, for solution showing positive deviation from Raoult's law. There is an intermediate composition for which vapors or which vapor pressure maximum and boiling is minimum. boiling is minimum. Yes, that means vapor pressure is inversely proportional to boiling. Vapor pressure is inversely proportional to boiling. Yes. At that composition, solution behaves pure liquid. At that composition, at that composition, at that composition, solution behaves as a pure liquid, and we cannot separate the components. We cannot separate the components. Cannot separate the components. Let's take the example. For example, rectified spirit. Rectified spirit, ethanol 95.5 percentage. Ethanol is 95.5 percentage. Water H2O, it is 4.50 percentage. Boiling point is 351.5 kelvins. 351.5 kelvins. At that temperature, constant temperature, the composition is ethanol is 95.5 percentage and water is 4.0 percentage. This is the azeotropic mixture. Azeotropic mixture with minimum boiling azeotrope. Minimum boiling isotropes. Yes, let's take example. Look at the example. For example, if it is a temperature, yes, it is a temperature, water is a temperature is a 373 kelvins. Yes. It is a 95.5 percentage ethanol. Yes. It is a 100% water. It is a 100% ethanol. The temperature is, it is a 351.5 kelvins. It is a 351.3. It is a 351.3. This point, the composition, liquid and vapor phase, the composition is 95 percentage, water is a 4.0. It boils at 351.5 kelvins. This point is, in this point it has vapors and liquids. It has vapors and liquids. In this is about minimum boiling azeotrope. Let's move on. Next, maximum boiling azeotropes. What does mean maximum boiling azeotrope? See, maximum boiling azeotropes. Maximum boiling azeotrope. Maximum boiling azeotropes are the mixtures two liquids whose boiling point is more than either of the two components. They are formed by non-ideal solution shows negative deviation. Negative deviation. See, maximum boiling azeotropes. Maximum boiling azeotropes. Maximum boiling azeotropes are the mixtures of two liquids whose boiling point is more than either of two components yes, they are formed by non-ideal solution. They are formed by non-ideal solution showing negative deviation from Raoult's law. Negative deviation from Raoult's law. Yes. For solution showing negative deviation, see, for solution showing negative deviation, there is a point for which vapors is minimum at point maximum boiling. There is a point for which vapor pressure is minimum. Vapor pressure is a minimum. At that point, and maximum boiling by non-ideal solution with negative deviation. Yes. In this, an intermediate composition, vapor pressure is the minimum, and boiling is the maximum. At that composition, solution behaves as pure liquid. We cannot separate the components. Yes, an intermediate composition, vapor pressure is the minimum, and that boiling is the maximum. At that composition, solution behaves as a pure liquid, and we cannot separate the components. The composition of maximum boiling point of azeotrope has more boiling point than both the components. See, the composition of maximum boiling is maximum maximum boiling at azeotrope has more boiling point than both the components. Example: water and HNO3. Water and HNO3. HNO3 68% plus water 32%. Its boiling point is 393.5 kelvins. Its boiling point is 393.5 kelvins. The condition is maximum boiling point of azeotrope more boiling point than both components. Let's move on. Temperature and percentage of water. This is the maximum boiling azeotrope. It is the 383 Kelvin temperature. It is a 373 Kelvin temperature. It is a liquid. At the above 373, it is a vapor. 188 Kelvin. Percentage of the water. HCl and water. For example, these are vapors. These are liquids. Boiling point for HCl water mixture leading the maximum boiling azeotrope. Yes, this is about azeotropic mixtures and types of azeotrope. Let's once again see the isotropic mixture. Exotropic mixture. Two liquids boils at constant temperature and can distill unchanged their composition. Here I am taking A and B. A and B is the liquids are to form AB liquid. AB liquid has constant boiling point. Constant boiling point has same composition of liquid. It liquid vapors and vapor phase. Liquid phase or vapor phase has same composition. That boiling point is a constant. That type of solution is a exotropic mixture. They are formed non-ideal solution. Yes, next. Generally, the exotropic mixtures are classified into two types. They are minimum boiling azeotropes and maximum boiling azeotrope. First of all, minimum boiling azeotrope. Minimum boiling azeotropes are the mixtures two liquids has boiling point less than either of the two pure components. See, the two liquids whose boiling point is less than either of two pure components. They are shows non-ideal solution positive deviation which are formed by non-ideal solution showing positive deviation from Raoult's law. Positive deviation from Raoult's law. They are minimum boiling isotopes. See, in this the solution shows positive deviation from Raoult's law. There is an intermediate composition which vapor pressure is the maximum, boiling is the minimum. Vapor pressure is the maximum and boiling is the minimum. So vapor pressure is inversely proportional to boiling. At that composition, solution behaves as pure liquid. We cannot separate the composition. That is, for example, rectified spirit is ethanol 95.5% and water is a 4.5%. It boils at 351.5 kelvins. So what is the boiling point of water? It is a 373. Yes, ethanol is a 351.3. The boiling point is less or more 351.15 is the boiling point. So actual boiling point of ethanol is 351.3. Yes, look at this point is liquid phase and vapor phase has same composition. Liquid phase and vapor phase has same composition. That point is 351.5. Next, maximum boiling isotopes. Maximum boiling isotopes are the mixtures two liquid whose boiling point is more than either of two components. They are formed by non-ideal solution shows negative deviation from Raoult's law. For solution showing negative deviation, there is a point where vapor phase is minimum, boiling is the maximum. Maximum is the boiling. At that composition, solution behaves as pure liquid. We cannot separate the components. The composition is maximum boiling point of the isotopes as more boiling point than both the components. Example, water and nitric acid. Nitric acid 68%, water is 32%, boiling point is 393.5 kelvins. Look at this. At this point, this is the point. In this point, liquid phase and vapor phase has same composition. Boiling point diagram for HCl and water leading the maximum boiling isotope. This is about isotropic mixtures. Thank you.